Hello, this is Jennifer Martinez. In this video, we're going to work with linear equations instead of linear expressions. When do we work with linear equations? Well, when we're interested in knowing which input values to a linear function gives a particular output value. So for instance, let's look at example 1. Example 1 says a car rental company A charges an initial fee of $25 plus 17 cents per mile that you drive the car, where company B charges $15 plus 22 cents a mile. So initially, company B seems cheaper, they're only $15, but the per mile is more expensive. So, which company is cheaper for the 300-mile trip, for a 300-mile trip? So let's go ahead and look at part A. So what I'm going to do is I'm going to find a formula for each of these, and I'm going to use the y equals mx plus b, or maybe even easier, y equals b plus mx, because they like to put the b first in the book, and this is why they do. So let's look at company A. So let's let y equal mx. So let's do that first. Y is we want to find rental company charges. So I'm going to make that the amount it charges, the cost for company A, or cost of company A, and let x be the miles, right? Because this is in per mile. So this would be the number of miles that you travel. So then in this case, y would equal, so $25 is the initial fee, plus 17 cents per mile, so it's 0.17 every mile. So if you go 1 mile, you just add 17 cents. Go 2 miles, you take 17 cents times 2. So you can see where this formula is kind of useful. And obviously the B is the initial amount and the M is the slope. That's company A. Let's say company B. So what is company B? Let's do a different letter here. So let's make this maybe a 1 for company A. And then all I'm going to do is change this to cost of or for company B. And then y sub 2, or you can call it A and B if you wanted, if you prefer, would be $15 plus 22 cents a mile, so 15 plus that slope, which is 0.22, times x. So which company is cheaper? So if I look at y1, company A here, just move that down a little bit, and I plug in a 300, that means take 300 times 17 cents, that's how much we'd be paying for 300 miles, and then we add that 25, you would get 76. So the cost that you would have to pay if you chose company A would be $76 for 300 miles. What about company B? So let's do the same thing for company B, put in a 300, and what would we get there? 81. What I do is I took my calculator and multiplied 0.22 times 300, then added 15, I got $81. So it looks like company A is cheaper. Company A is cheaper if you travel 300 miles. But is this always the case? Is there a distance that we can go where company B would be cheaper? So before we answer that question, let's look at part B. At what distance are the costs the same? It says solve with a graph as well as the usual way. So see if you can try this. Pause it and see if you can get where company A and company B are the same. Did you get an answer? Well, here's what I got. I got it 200 miles. What I did to solve this, let me make this a little smaller so we can see the whole thing, is I set the cost of company A equal to the cost of company B. So I set y1 equal to y2. I end up with the equation. I decided to subtract the 0.17x to both sides. Don't let the decimals mess you up. And then I subtracted 15 from both sides, and I got 10 is equal to 0.05x, divided both sides by 0.05, 200. At x equals 200, the cost of each are the same. How would we solve this using a graph? My first step, I would go to y equals, and then I would type in my equations, the first one on y1 and the second one on y2. And don't forget that the xt theta, to press the, find the x, you have to use the xt theta button next to alpha. Then I'm going to go to graph. Probably going to need a different window than the Zoom 6, right? Let's go to window first. Otherwise, you won't be able to see your graph. So I'm going to type in this window. And the reason I chose this window is because if I remember, and we know we're going to get an answer of 200 on the x, and we were looking at 300, so I wanted something bigger than 300. So I chose 400 there. And I wanted to count by 100 if I'm going to do something as big as 400, but you can do whatever window you want. 0 to 30, why did I choose 30? Because my biggest y here. Well, actually, you know what? We might want a little bigger than that, because it's going to go up, isn't it? And I really don't know how much it's going to go up. So maybe I want to try as 100 there. Maybe that would be better. And I decided to count by tens. And finally, we're going to go to graph. There's one. I did make it large enough. Good. So you can see maybe 30 would not have been large enough. And there it is. So notice if you click on trace and go to the left, right here will show you where the cursor is, and it's on the higher one. So you can see that the cost is larger there. If I go to the down arrow, the cost of the second one is cheaper. This must be the 200 mark because it's at 400 there. The intersection, I should say, because is at the 200 mark. And if I go past that, this line that's on there, it's going to become more expensive. So you can kind of see that. If you choose second calc intersect, so I'm going to go ahead and try that. Hit the second button, the calc is above the trace, and then intersect. You can press 5 for intersect, or you can just scroll down. And then press enter 3 times. 1, 2, to answer each question, 3, it will give that to you, that intersection point, 200. And not only that, it would give you the cost of each if you plugged in 200, which would be $59. So let's go ahead and draw that. Here is a rough sketch. Let me see if I can get this whole thing to make it really small to see where the costs are the same. So the first equation, the first company starts off larger. This is company A, starts off larger. And then after 200, 300, it becomes cheaper. Company B starts off cheaper, but then after 200, becomes larger. Very interesting. So now let's look at example 2. It's a review on how to solve equations, since that's what we're going to be doing in this section. Solve each equation. Go ahead and try this. If you can. Okay, I'm going to go ahead and do the first one together because the first one's kind of tricky. So we want all the x's on one side, so I'm going to do is I'm just going to subtract 3x from both sides. And oh, what happens? This side, the x goes away, giving us 2. The right side, the x goes away, giving us 10. So we didn't have this in B.1. This is a little different. 2 cannot be 10. That doesn't make sense. And the x's go away. So here is a case where there's no solution. Let's look at example B. So what I'm going to do with example B is I'm going to get rid of the parentheses. And I'm going to combine like terms. So I'm going to subtract the 3x here as well. And you get almost the same thing as part A, that they go away. But Now, we've never had this before either. 2 equals 2. So unlike part A, these are equal. So this is going to be, everything's going to be a solution. If you look at the left, it's the same as the right. It's the same expression. So this is all real numbers. So when the x goes away, you're either going to have 2 choices. No solution when they're not equal, or when they're equal, all real numbers. There's 3 choices for any solution of a linear equation. Again, these are all linear. You're either going to have no solution, all real numbers, or one answer, like we did in our review of chapter B, or section B. So let's go ahead and do the example of this. I'm going to add x to both sides. Notice how the x does not go away. Oh, there is something new here, though. The numbers go away, but that's okay. 4x equals 0. Don't let that confuse you. That's not one of these. This is a normal problem with one solution, because I'm going to divide by 4, and 0 over 4 is 0. So that would be the answer to all 3. Let's do an analysis of this on the next page. These are what the graphs look like for each of those 3 cases. A linear equation can have one solution, no solution, or all real numbers. An infinite number of solutions is what they say. If it is written in the form f of x equals g of x. So this was like my y1 in the example with the rental company A, and this is like my y2 with the rental company B. So let's call this f, this line f, and this g. If you have 2 lines, they can either intersect at one point. They can never intersect, look like that, never intersect. Or the 2 expressions could just be the same. So obviously there's more than one solution in an infinite number. So go ahead and try this. Solve each equation, check your solutions by plugging them into the original equations, and see where they fit. Are you ready for the solutions? Here they are. Here are the answers for the first 3. The first 2 came out normal. So if you can check them on your own by plugging 150 and see if it does work. The same with this one, part B. Part C is the new type. There is no solution there. You subtract 16 and you do not get a solution because 15 does not equal 0. So if you graph this left side on your calculator, you graph this right side of the calculator, you end up with parallel lines like that middle one there, where they never intersect. D and E, the solutions to those are coming now. So part D just had one solution. That one was back to being normal. But part E, so let's go ahead. I know that's a decimal there. I went and multiplied these. I added these together, subtracted that 0.05 D from both sides, and they went away. The left side was 50 and the right side was 50. They were the same, so that's where it's the infinite number solutions. These turn out to be the same line, where part C, they were parallel lines. You could also have said that. There is 2 fancy words to know in the future that we're going to get for things that are no solution. Sometimes they call that inconsistent. They're inconsistent because there's no consistent point where they intersect. And for part E, the fancy word they come up with here is dependent. They sometimes call this dependent. And the reason they call it dependent is because they are the same line. They are very dependent on each other. So dependent that they're the same. And here's make this smaller so that way you can see the no solution are parallel lines, and the dependent is the same line. That's it for this video. Try exercise 2 in the next video.